Assalamualaikum and a very good day to my lecturer. So today our group will present about the quadrature amplitude modulation for the communication principle. So for the contents of this video, it consists of introduction of members, theory about the circuit, explanation about the quadrature amplitude modulation or QAM, and the demonstration of the circuit works, and the last one is the overall summary. So for the introduction of member, first of all, it is me, Muhammad FIRDAUS bin ANUWAR, for the introduction and the theory. Then we have Muhammad HAIKAL bin ARIFFIN for the explanation of the circuit. We have Muhammad AMIR bin ZULKIFLI for the demonstration of the circuit, and the last one is Muhammad SYAFIQ bin AKMAL AZIZ for the overall summary. So the theory about the circuit. Basically, we must know what is QAM or the quadrature amplitude modulation. It is a method of combining two amplitude modulated AM signal into a single channel, thereby it's doubling the effective bandwidth. Then, QAM is used with pulse amplitude modulation in digital system, especially in wireless applications. So if you see this figure, there are two carriers, each having the same frequency but differing in phase by 90 degrees. One signal is called the I signal and the other one is called the Q signal. As you can see here, on the top one is the I signal and the bottom one is the Q signal, and both are in the same frequency. Why? Because you can see they having the same wavelength and they are different in phase by 90 degrees. You can see for the I signal, it starts with a 0, but for the Q signal, it's starting with a 1. So one of the signals can be represented by sine wave. You can see for the I signal, it was starting by sine wave, and the other by a cosine wave. For the Q signal, starting with 1, this is a cosine wave. The two modulated carriers are combined at the source for transmission. At the destination, the carriers are separate. The data is extracted from each, and then the data is combined into the original modulating information. That's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAIKAL bin ARIFFIN. So I want to present about explanation of modulation technique for 16 QAM. QAM is a method of combining two amplitude and phase modulation signals into a single channel. QAM has two carriers with the same frequency but different in phase by 90 degrees, known as the I signal in phase and Q signal quadrature data waveform. QAM is based on the application of ASK and PSK to two sinusoidal waves of the same frequency but with a phase difference of 90 degrees. Sinusoidal waves 90 degrees apart are said to be in a quadrature phase relationship. It is customary to refer to one of these waves as the I wave component and the other as the Q wave component. So we can see here is the example for I wave and Q wave. The A I wave is starting from 0 and the B Q wave is starting, we can see here, starting from 1. So that means A for sine and B for cosine wave. Next is the QAM modulator. The two resultant signals are summed and then processed as recorded in the RF signal chain. The amplitude of the signal varies. Any RF amplifiers must be linear to preserve the integrity of the signal. Any non-linearities will alter the relative levels of the signals and they alter the phase difference, thereby distorting his signal and introducing the possibility of data errors. QAM demodulator. The QAM demodulator is very much the reverse of the QAM modulator. The signals enter the system, they are split and each side is applied to a mixer. One half has the in-phase local oscillator applied and the other half has the quadrature oscillator signal applied. A further requirement is to derive a local oscillator signal for the demodulation that is exactly on the required frequency for the signal. Constellation diagram 60 QAM can be used with variety of different format as 16 to 64, 64 to 256 QAM, and etc. The QAM order increases, so the distance between the different points on the constellation diagram decreases and there is a higher possibility of data errors being introduced. The constellation points are usually arranged in a square grid, also in hexagonal or triangular grid. Here we can see the transition of or shift of the amplitude, phase and data symbol of 16 QAM. Here we can see the changing of both signal I and Q signal waveform. Analog QM modulate two carriers to 90 degrees out of phase with each from two analog input streams. The modulated carriers are combined and transmit. Here also we can see here is a combination analog and digital waveform. Thanks for me.
So this is a demo for the simulation of a 60 COM. For this simulation, we have a random integer generator that uniformly generate distributed random integers that's specified by the set size parameter, which is for this block, which is 16. The data that are generated will be modulated by COM modulator. Next, we have a rectangular COM modulator baseband, which modulated the input signal, which the data from random integer generator, which carry two carriers shifted in phase by 90 degrees in both sine and cosine wave, where they are both modulated and combined. One carrier is called the in-phase signal, I signal, and the other are called the quadrature signal, Q signal. And combine these two carriers and we have a new signal that contain both amplitude and phase variation. So this one is a AWGN channel. AWGN stands for additive white Gaussian noise. It's a basic noise model used in information theory to imitate the effect of many random processes that occur in nature based on the parameter we insert. Okay, for this one is the rectangular COM demodulator baseband, which act as the opposite for the modulator, which reverse the COM modulator, which in this baseband, where the signals split and apply to the mixer, where the signal will be demodulated and the signals returns the same or similar to the input signals. Okay, these are the constellation diagram, show the different positions for the states within different forms of COM, which based on the number of bits per symbol, in this case is 4 quad bits, based on 60 COM, which based on in-phase and quadrature diagram. And as for the result, this side here shows the input wave before modulation, and down here is signal where both in-phase and quadrature signals are summed, thus result in combined signals that vary in amplitude and phase. And for the constellation diagram, shows where the constellation points that are mapped, where this yellow dot represent a random noise processed by the white Gaussian noise that deviate from the ideal constellation points. So in sense of a demodulated signal, demodulated signal should be the same as the input signal before modulation.
The advantages of QAM. One of the best advantage of QAM support a high data rate, so the number of bits can be carried by the carrier signal. Because of this advantage, it's preferable in wireless communication network. QAM noise immunity is very high. Due to this, noise interference is very less. It has low probability of error value. QAM expertly uses channel bandwidth. The disadvantages of QAM, as states are more close as shown in the figure. QAM modulation is more susceptible to the noise. Due to this, QAM receiver is more complex compared to receiver of other modulation type. As QAM uses amplitude component of signal to represent the binary data, linearity need to be maintained, and hence linear amplifier is needed, which consumes more power. The application of QAM. The application of QAM are mostly observed in radio communication and data delivery application system. QAM technique has wide application in the radio communication field because as the increment of the data rate, there is the chance of noise increment, but this QAM technique is not affected by noise interference. Hence, there is an easy mode of signal transmission can be possible with this QAM. QAM has wide application in transmitting digital signal like digital cable, television, and the internet services. In cellular technology, wireless device technology, quadrature amplitude modulation is preferred. For the summary, although QAM appear to increase the efficiency of transmission for radio communication system by utilizing both amplitude and phase variation, it has the number of drawbacks. The first is that it is most susceptible to noise because the states are closer together, so that the lower level noise is needed to move the signal to a different decision point. Receivers for use with phase or frequency modulation are both able to use limiting amplifiers that are able to remove any amplitude noise and thereby improve the noise reliances. This is not the case with QAM. The second limitation is also associated with the amplitude or component of the signal. When a phase or frequency modulated signal is amplified in the radio transmitter, there is no need to use a linear amplifier, whereas when using QAM that contain an amplitude component, linearity must be maintained. Unfortunately, linear amplifiers are less efficient and consume more power, and this make them less attractive for mobile application. That's all for today. Thank you very much for watching and have a good day.